Sure, we want to start with the first one. It says number 10.
Yeah, it's because this is part 2, and then the next page is part 3.
Okay.
Yeah. All right.
Weird. All these Windows InkPad, everything was running really slow earlier.
Really?
Well, yeah, when I was writing on my tablet, it was showing up about a half-second delayed,
Huh.
and I had to reboot everything and unplug my tablet, plug it back in. That solved the problem.
Okay.
Okay, so what's the first step we're going to do to make this into a single log expression?
Well, we know it's going to be. Let me see. Let me see. Is it going to be a fraction,
Yeah,
like log base
the
2, and then a
argument
fraction?
will be a fraction.
Mm-hmm.
In other words, here's the rules that we're talking about.
Okay.
I'm going to write them, but you need to memorize them.
Okay.
You're not going to get a cheat sheet or anything, are you?
No.
Well, then you got to memorize them in no time like the present. What's the rest of this?
So log of A is equal to log A.
Plus the log of b.
Oh, that's it.
In other words,
Okay.
when you are multiplying inside the argument, you're adding the two logs.
Mm-hmm.
When you are dividing inside the argument, what are you doing to the two logs?
Multiplying them
Division
or
is what I mean.
subtracting.
When you're
Oh,
dividing, you're subtracting.
yeah.
Okay.
Right. Okay.
Fraction goes with division. Addition goes with multiplication. And there's a third one. When you are double exponentiating, that's what I call it.
Mm-hmm.
In other words, yeah, no, sorry, I didn't mean double exponentiation.
No, you're good.
That's the rules for exponents. For logs, when you are exponentiating, what's the answer?
Exponentiating square root.
You just bring the exponent down in front.
Oh, okay. That makes sense.
Now, these three rules, if you can't memorize these three rules, you're not getting any of these log problems right.
Mm-hmm.
Every one of
It's
them
these.
based on them.
Mm-hmm. It's kind of easy to memorize too.
Every time they give you something to expand or compress, you have to use pretty much all three of these rules.
Okay.
Now,
They're easy to memorize too.
well, they are easy to memorize, but you got to go both ways. In other words,
Right.
in this case, we got to go from right to left.
Mm-hmm. Exactly.
And the one
Yeah.
when you're condensing, the first thing to deal with is that b that's in front of the log. Do we have one of those?
Being no.
How about the 4?
Before.
Right here.
Yeah, we do.
Okay.
Yeah. I
So
was
we deal
looking.
with that first. How do I deal with it?
Um.
Remember, we're going from right to left. Right now, we're looking at 4 log of a. What do we have to turn that into?
4 log of A, we have to turn into. Huh.
Go backwards.
An
That third
exponent.
rule says.
Yeah, we
Go
have to
back.
turn it into an exponent.
Okay, so what does that turn it into?
Would it just be log 2 of 4?
No, turn it into an exponent. It goes right there.
Log 2 is. Yeah, log base 2 of x to the 4th. Okay.
Okay?
Okay.
And those you always do first when you're going this direction.
Okay.
That disappears. So now I got that. Okay? Now I'm going to erase everything.
Okay.
I want you to memorize it. There's no way you memorize it if I leave it up there. So all you do is read it and do it. That's
Right.
not the way to memorize anything.
No.
You've got to try to memorize and then try to recall. If you make a mistake, I'll tell you. But then you
Okay.
try again next time. And do that a couple times and you've got it memorized.
Mm-hmm.
Okay. Now, let's do each of these alone. What do those two mean? If I change that into one expression only, it's log base 2 of what?
3x squared plus 3x.
Not 3x squared. It's 3x times x plus 1.
Okay.
In other words, we have two logs that are being added together. That means we can turn it into one log where those arguments are multiplied together.
Okay.
And then we have another log over here that's being subtracted, which puts it in the denominator of the argument.
Right.
As x to the fourth.
Cool.
And that's your answer.
Okay.
You could further distribute the numerator if you wanted to, but I don't think it's a good idea. In fact, let's simplify this. In other words, I can do some simplification in that argument. What can I do? And you always want to. You always want to simplify the argument. You don't necessarily multiply together terms. I like factored better than non-factored, and there's a good reason. Because if this was in multiplied form, I wouldn't necessarily see that I can simplify it. But the fact is that I've got an x in the numerator and an x to the fourth in the denominator. What does that change?
X. Well, the x's can cancel out.
Well, one of the x's
cancels
out with one of the numerator exponents. Now I have 3 times x plus 1 in the numerator. No longer have that x, and I only have x to the third in the denominator. And that really is the best final answer. And I can't simplify it anymore. There's no way to simplify it further. So that's what you really have to do, is you have to know those 3 rules backwards and forwards. And I mean that literally.
Yeah.
Okay?
Okay.
All right. Now it's slow again.
Is it slow?
Yeah, notice I clicked on that wink. Can you see that Windows ink workspace down there?
Yeah, it just came up.
Click on that. It normally brings up this window and then lets me take a snapshot of the screen, which I can then write on.
Does it not let you do that?
It's been working weird lately. It's either a bug in my computer or a bug with Windows ink workspace or my tablet. I don't think it's my tablet, because my tablet's not involved in taking a screenshot of it.
Right.
Suppose I could do it with Paint. I mean, you can do a control print screen and paste it into Paint, and then I could draw on it.
That's just a pain to do.
Yeah, this works so nicely most of the time.
Yeah.
Now, normally when you have an exponential equation, why is that an exponential equation?
Because that's
11a. Why is that an exponential equation?
Because it has exponents on both sides.
No.
A
variable is in the exponent. There is a huge difference between x squared and 2 to the x. That is an algebraic expression. That is an exponential expression.
Okay.
You cannot solve these algebraically. Unless they are of a very special kind. Like A, 11a, is a very special kind of exponential equation.
Okay.
Normally, you would have to use logs. In other words, you'd have to take the log of both sides, and that would allow you to bring the x down in front. Then you'd have an algebraic equation that you could solve. When you notice something similar between those numbers, you can do it in an easier way.
Okay.
Now, since this is an exponential equation, think exponents, not factors.
Mm-hmm.
What is the common exponential base between 9 and 27?
3.
Tell me how to write 9 with 3 as the base.
3 to the third.
9 is 3 squared.
Squared, I mean, don't know why I just said it. Yeah, I was thinking 3 times 3 is 3 squared.
How do I write 27?
So it'd be 3 squared, hold on. 3 to the third. 3 times 3 times 3.
So that's the same thing, right?
Yeah.
In other words, that's 9, that's 27. Exponents
Mm-hmm.
are what they were to begin with.
Right.
But now I can apply the rules of exponents. Now I have what I would normally call double exponentiation. This one's being exponentiated and it's further exponentiated. So how do you
Okay.
handle double exponentiation? What do you do with the exponents?
Don't you just set them equal to each other?
Multiply them. First of all, you got to multiply them.
So, okay.
In other words, when you have double exponentiation, you multiply that times the 2. So it becomes minus 2x
Oh,
plus
that makes
30
sense.
is the exponent on the left side of the equation. What's
Oh, okay.
the right side of the equation now become?
Just 3x.
What's the right side of the equation become? Use the rules of exponents. When you are doing double exponentiation, what do you do to the 2 exponents? I got an
Multiply
exponent
them.
here, I got another exponent here. You multiply them. So the answer
Right.
is
Just
3 to the 3x.
right.
Okay.
Uh-huh.
Now I have one base to one exponent, and I have the same base to a different exponent.
Okay.
Now you can equate the exponents. They have to be equal to one another. In other words, minus 2x plus 30 has to be equal to 3x.
That makes sense.
And solve that. Take the 2x over to the other side. You get 5x equals 30, x equals 6.
Mm-hmm.
And if I put 6 in there, then it'll be 9 to the 9th power is equal to 27 to the 6th power. And that's a true statement. Your
That
calculator
is your
will
statement.
verify that.
Yeah.
Okay?
Cool.
That's the easy way to do it. Without
Yeah. It gets harder.
logs.
Mm-hmm.
Okay?
Okay.
So, now let's look at the second one. What kind of an equation is that? Is that algebraic or exponential?
Exponential.
Correct.
Mm-hmm.
Now, the question is how we're going to solve it.
Yeah. Won't the first step be to just get rid of the denominator?
Very good. How do I do that?
So it's denominator is e squared, which is square both sides.
How do I
No.
get rid of a denominator? Always, whenever you're
Just
solving an equation.
multiplying, so multiply both sides by e
by
squared.
the denominator, right?
Yeah.
Okay, so the left side becomes e squared times e to the x squared, right?
Okay.
And the right side becomes what?
E squared times e to the 3x
The e
times 1.
squareds cancel out. That's why we're multiplying both sides by e squared.
So it'd just be e to the 3. Yeah, 3x.
Okay. Now, can't equate anything yet because we got to simplify that. Again, you got to use the rules of exponents. When I am multiplying the bases, what do I do with the exponents?
When you're you multiply them.
No, you never do the same thing.
Wait,
You
on
do
the
one
on the same
level
side.
less. You add them.
On the same side. Okay.
Well, this is what we're talking about. We're talking about b to the x times b to the y is equal to b to the x plus y.
Okay.
These are the same rules for logarithms, kind of in reverse.
Yeah.
And notice that logs are exponents. So whatever rules you use for exponents, the same ones for logs. When you're multiplying, it separates into addition.
Okay.
When you are dividing, it separates into subtraction. And when you are double exponentiating, it separates into bringing the top exponent, putting it down in front of the base. So it's the same three rules. It just looks a little different. But you got to memorize them. I mean, you're in a section where you're gonna go 0 for 20 if you don't know these rules.
Oh yeah, for sure.
That's your only option. It's like going out on a baseball field with no arms.
Yeah, you just can't.
Field grounders. You're gonna go 0 for 20.
Right.
Okay. Well, you don't want to. So all you got to do is memorize these rules. Okay. So what's the left become? I'm multiplying same base. What am I going to do with the exponents?
You add them.
Okay,
so it would be just 2x, e to the 2x squared.
No. You're going to add them. That's adding. I'm adding the exponents.
Okay.
Okay. That whole thing, the right side didn't change.
No.
Now I have same base on both sides, different exponents. So what can I say?
Like you set them equal to each other.
Okay, so I got x squared plus 2. I'm going to rearrange it.
Yeah.
Equals 3x. Well, okay, I'll do that step. And then I got x squared minus 3x plus 2 equals 0. Now what do you do?
Factor.
Okay, into what?
X minus 2, then x minus 1.
So what are my solutions?
X is equal to 2 and 1.
Okay.
Cool.
Hold on. Not quite done because we need to go back and make sure those solutions work.
Exactly.
We're not sure. One of them could be extraneous. Whenever you've dealt with a quadratic and you come up with two solutions, it never hurts to check them. Well, let's see if we get something that looks reasonable. Let's try the 2. So we got e to the 2 squared, which is 4. Is that equal to e to the 6th times 1 over e squared? Is that an equation that's proper?
No. That's proper?
Yeah. Well, in other words, you got to figure out what that is. What is that? What's e to the 6th times 1 over e squared?
E to the 3rd.
What do you do with the exponents when you're dividing?
You subtract them.
So what's 6 minus 2?
E to the 4th.
Okay. So we get e to the 4th equals e to the 4th. Everything's copacetic. That's a proper answer.
Okay.
Now let's check the other one. Let's check 1. What does that give us?
Oh, where's my calculator? My calculator
You don't need a calculator. Calculator would hurt you here.
Oh, no, I know. I'm just saying I was going to go turn it on. My calculator's dead.
But it would hurt you because you don't want to be putting in e into your calculator. That's an irrational number that'll just complicate things. This is an extremely simple problem. You don't need a calculator for it.
No.
So I'm trying 1. Plug it in. Tell me what the left side of the equation is.
E to the 2nd is equal to...
Hold on.
E to...
Evaluate that when x equals 1.
1 squared, which is 1.
Okay. So what's e to?
E to the 1st.
Okay. Just not e squared. You said e squared at first.
Did I say e squared?
Yes.
Oh, I was confused. No, I didn't mean to say that. My bad.
I think you do that a lot. And
I do. I don't know why.
and misinterpret it thinking you don't know how to do the problem. And in reality, you generally do know how to do the problem. And if you're writing an answer, you probably do better.
Yeah. Oh no, I do
What I
much
think
better when
what
I'm writing.
happens is you know the answer, you don't say it right.
Yeah.
And in one regard, I don't know if that makes online tutoring better for you because you do need more practice at saying what you're thinking.
Yeah.
You can't be saying something different than you're thinking, especially in an online tutoring session, because I depend on your verbal answers. Whereas when you're taking a test, you're writing the answer out.
Right.
So write it out if you have to, and then read to me what you wrote.
Okay. So it'd be e to the first is equal to e to the third times 1 over e to the second again.
What is e to the third over e to the second?
E to the first. So
Okay.
that
We
works
got
too.
e to the first equal. E equals e. So both solutions work. Okay.
Yeah.
Well, I really do think that happens a lot. And I frequently come to the wrong conclusion as to what you know and what you don't know. How do you solve a logarithmic equation?
Oh, you do the I do this. So it would just be 3 to the x is equal to 1, or yeah, 3 to the x is equal to 1/8.
Backward.
Or
Start
do I
from
have
the
it backwards?
left, always.
Okay. 1/8 3 to
No,
the
the
x is
left
equal to 3.
is that.
So start
No,
with x.
it's the number or letter on the far left raised to the right side equals 1/8.
Okay.
Now you have to solve that.
Hmm.
And this is a little tricky only because most people don't handle cube roots of fractions very well. But how do I solve this? X clearly is not 2, right?
Right.
2 cubed
So
would be
-2.
8, but what must
Neg
x be such that x cubed would be 1/8?
-2.
Negative 2 cubed would be -8.
Would it? Yeah, it would.
How about this?
2 to the minus third?
We can't change the 3. The
No.
3 has to stay the same. You're right. 2 to the minus 3 would give us 1/8. But we don't have any choice about the exponent. It's 3. What we do have a choice is what we can make x. And notice that 1/2 cubed is 1/8. 1/2 times 1/2 is 1/4 times another 1/2 is 1/8.
Okay.
So when you square or cube fractions, they get smaller. They don't get bigger. They get smaller.
No.
And that's what throws most people off.
Mm-hmm.
Okay. So
Okay.
x is 1/2 for C. All right, I think we got time for one more.
Yeah.
Okay. No way to solve this without condensing it first. Because if I can condense it to a single log expression, then I can convert it to exponential and solve it.
Right.
Well, what goes in the argument? There's my single log expression.
Right.
When you add 2 logs and you condense it, what do you do to the arguments?
You multiply them.
Perfect. And that actually multiplies out. I'm going to multiply them together just
Right.
to demonstrate something. 4x and 1x is 5x. So there's my new argument. And now what can I say? Now to solve for x, I need to put this in exponential format. So give me an equation.
3 squared is equal to x squared plus 5x plus 4.
Perfect. That's 9. Now what? Now I'm looking at a quadratic. How do I?
Right, now you just factor it. So it'd be 9 is equal to x plus 4 and then x plus 1.
Nope, you won't be able to solve it that way. In other words, if I can factor this,
I think, yeah, because then you would just set 9 equal to x plus 4 and then, or 9 equal to x plus 1.
no, you can't do that. The reason is, no, here's what happens.
Okay.
I can't, and this is an important math concept here. The only reason we factor stuff is if it's equal to 0. Because you know that if two things multiply together equal to 0, you can set each one of them equal to 0. But if they're equal to a number, if I tell you a times b equals 10, well, you can't solve that.
No.
A could be 1, b could be 10, a could be 2, b could be 5, a could be minus 2, b could be minus 5. There's literally an infinite number of solutions. But if I set it equal to 0, then a has to be 0 and b has to be 0, or one of them has to be 0.
Right.
So you never leave a number on the other side, not if you're going to solve it by factoring a normal quadratic factoring. What do you got to do? You got to move that number out of there. You got to get the 9 on the other side. Unfortunately, that's not going to leave a very pleasant looking quadratic, but so what do I do? What's the next line?
0 is equal to x squared plus 5x plus minus 5. Or, yeah.
That's minus 5. You don't need to put the plus minus 5. It's just minus 5.
No.
And notice that that does not factor. There are no factors of 5 that subtract to the number 5.
No.
So, did I make a mistake?
So this was non-factorable.
That was 4x. That was another x to give you 5x. I don't think I made a mistake.
No,
now, how do you solve this for x? In other words, you still have to solve for x.
You can use a quadratic formula.
Okay, yes. We're out of time, so I got to go. But let's just pretend that I came up with square root of 3 and minus square root of 3. Which one of those answers doesn't work?
The negative root 3.
Because you cannot take the log of a negative number. And if I put negative root 3 in for x, that argument is negative.
Exactly.
That's like taking the square root of a negative number. You cannot do it.
No.
So you throw out that solution and you use only that solution. And with logs, that happens a lot.
Okay.
In other words, you end up having a quadratic to solve by factoring or the quadratic formula. And then one of the solutions is negative or causes one of your arguments to be negative. And you never plug it into this to check. You always have to go to the original equation. Always. Because you cannot violate either of those domains.
Right.
Dylan, I'm going to let you go. I do have times available on Monday and Tuesday if you need one.
Okay. Our finals tomorrow.
Okay.
So yeah, so I'll be good.
Good. Very good luck on your final, and
I feel pretty good about this.
Happy New Year to you and your whole family.
You too.
I'll talk to you next semester, probably.
Sounds good. I'll see you next year.
All right.
All right.
It was like saying that.